Yeah, g'day YouTubers. Tinker O'Toole again with another video. Today we're going to talk about the Hercus 9A lathe. This particular model here was made in 1953, so it's 72 years old. So I guess the first thing to do is talk about the motor. The motor is a single phase motor. You can get them in three phase, which would be a little bit stronger. But nonetheless, it's a single phase motor, so it's good for home use. The motor has two pulleys on it, and so you've got two speeds. So you've got two pulleys there and a much larger pulley here. So you can swap between one speed and another speed, and that's just a matter of pulling this lever down like this, and then the belts come loose, and then just moving them into the correct position that's required. As well as four pulleys on here and the four pulleys on this side, and that's a matter of moving the belt to the desired speed. Typically, you've also got a back gear fitted to this. This will really put it in slow RPM of about 70. So depending on the motor that you've got, you typically, with your slow speed on your back gear, 70 RPM up to about 1,400. So that's about the speed that you've got. Three-jaw chuck, about 5 inches in diameter, and we've got a four-jaw chuck up there, as you can see. That's about 6-inch diameter, plus a whole bunch of other fittings. Okay, the back gear, as I said, enables the lathe to go to about 70 RPM, which is fantastic for thread cutting, especially if you're thread cutting against a shoulder. So yeah, you really want to go slow speed, because if you're going to come up against the shoulder, the last thing you want to do is smash the tooling into the work that you're cutting. So yeah, be very careful of that. Now, the next thing we'll talk about is the gears that are on the back here. So we'll talk about those briefly, and we'll talk about this particular lathe. When it came out, was imperial. It was converted to metric. Fairly simple process of changing some gears, as well as identification plate, and in conjunction using this plate here, which gives you the lever positions to use. So the first thing I want to talk about is that the spindle has a gear here, and then we've got these tumble gears. The one at the front is for forward, and the one at the back is for reverse, and it's a matter of loosening the square nut and adjusting that. Now, where do you want to use reverse on this would be that if you want to cut in the opposite direction. Normally we cut, the cutting bit goes towards the chuck. You may want the cutting bit to travel away from the chuck, because maybe you're going into a shoulder or into a tight little spot. Maybe you've got a piece of metal and it may have some shoulders on it, left or right. So that would be the reason why you'd want to go backwards and forwards. This particular lathe does have electrical reverse on it as well. So that's another thing that's also used for cutting threads. The next gear that's interchangeable, depending on when you're doing threads, is the stud gear. So it's this one here. There is another gear behind it that hooks up to these idler gears. So the next set of gears is this compound gear here, which is the metric conversion, and it's 127 teeth here, and it's got 100 teeth here, and it goes to the 56 tooth, which goes to the gearbox. So that's the gear arrangement, and I've got many other gears. I've got 48 teeth, I've got 40 teeth, 36, 28, 20. There's a whole bunch of gears up on the back wall. I think you might be able to see some of them there. There's some of the back gears there, the 48's up the top there. So we've got a whole bunch of gears there. So yeah, that's used for the different pitches. when setting up for the metric threads, and we can go over that. Okay, if you've set your lathe up for metric, there's also another gear, I think it's 63 teeth or something. So there's more than just one way of setting this lathe up with different gears. Whether you use the compound gear that I've got, which is 127, and the 100 gear, which seems to be the most common. There is another version that's 63, a different combination. Now, this is the original plate that most people would have used when the lathe come out. It's imperial. You've got two sets of gear levers, and we'll zoom in and have a look at them in a minute. You've also got information for your stud gear. In this case here, they're only using 40 and 20 teeth, but you've also got on this gear lever, and we'll have a look at it in a minute, you've got A, B, C and D. Then you've got these arrows, 1, 2, 3, 4. There's 8 different columns. And then you've got this gear lever. So if we look at A, B, C and D, A is up the top, B is down the bottom, C, D is over, one more. So if we pull that down, so you've got A, B, C, D and E. Pretty straightforward. Over in the next column, you've got a gear lever that corresponds to these columns here. So this point corresponds to this arrow, and then the next arrow and the next arrow. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 of them, and they correspond to each of those columns. Now, when you get a set of metric gears, I also got a plate, a brass plate. And the brass plate tells you what gears to use for what pitch that you're going to use. And we'll put the brass plate up, and we'll try and zoom in on it and try to explain how it works for those that are interested. Over on this left hand side, we've got all the different pitches. So we go from 6mm pitch right down to the bottom, which is 0.4. Very, very fine. Now, the other day I did a 2mm pitch, which is this one here. You'll see the 20 there, and the 20 refers to the gear lever position. What that means, gear lever position, is if we look down further, when we done the 2mm, the 20 on the gear lever position refers to the 20 that's here. So what you've got to do in this column here, left-hand tumbler. So that's the left-hand tumbler here. So if you go back and have a look, it needs to be in the B position. The B position is down the bottom here. So then the next thing that you need to look at is this column that it's in. So you count 1, 2, 3, 4. So it's in the 4th. So it's 1, 2, 3, 4. This position. So depending on your thread will depend on where you put those gear levers. Also, depending on the pitch of the thread as to what stud gear. You can see you've got 48, 44, 40, 36, right down to 32. At the moment, I've got a stud gear of 40. And if you go across to when we done the 2mm, that uses 20 on the tumblers. And we also need a stud gear of 40 teeth. This is a compound gear, the metric compound gear, the 127-100. The 56, well, that's that gear here. So that's the 56 gear. So hopefully that makes sense that you use the metric plate and you use the different positions. You don't use this stud gear here, you go off the other chart, stud gear. So it's pretty straightforward once you understand that you look at the pitch, then you look at the different options that you've got. I'll just try and focus on that again. And those gear lever positions. So your millimetre pitch is your first, your gear lever positions, which are, they're your gear lever positions, right? So they're pretty straightforward, your gear lever positions. Your stud gear here, that's on the machine over there. So there's your stud gear. That's 40. Then the next thing, the 127 and the 100. That's this gear here, the 127 and the 100 here. And last column, the screw gear shaft, 56. It doesn't change for everything, and that's your 56. So hopefully that explains everything. Only one other thing that I'd like to say is that when you do change gears, a lot of the times that you have to loosen this. This is the banjo arm. Now this banjo arm does have movement. It can move backwards and forwards a little bit, and make sure that when you do change gears, that I've got a tiny gap between the two gears. Don't push it all that way, otherwise the gears will rub against each other. So just remember that, and just also remember that your forward and reverse on these tumble gears here, forward and reverse. Other thing to remember, this lathe loves to be oiled. Use hydraulic oil, right? 46 ISO, I think it is. Just make sure that you're using a good quality hydraulic oil, and make sure that you oil those gears every single time that you use the lathe. And while we're on the subject of oil, it's got these little flippy caps. You got one here, one here. You could zoom in there a little bit, you'll be able to see them a little bit better. Another one down here, another one up the top. You've also got some over on the carriage. You've got another one here. There's another one down the bottom there. Just remember that those flippy caps, that you need to oil these 4 points and the gearbox as well every single time you use the lathe. Just a little bit of a squirt there. So you can't go wrong. That's one of the things that's probably most important. Remember, this lathe is 72 years old. The other thing that's interesting, one of the reasons that it's really critical in oiling this, it has an oil reservoir under here. It has a little spring with a little bit of a wick. And that wick, this doesn't have bearings in this model. The later models did. This has cast iron bearings, right? So you got metal rubbing against the cast iron bearing. Be surprised how good it actually works. And you've got a little shim that's in here. That's your shim that you have for clearance. So the most important and critical thing is that you oil these every single time, because this is metal on metal bearing. The back bearing is different. It's got a series of roller bearings. It's different setup, and there's a proper procedure to tension this all up and get it all correct. We won't go into that. The next thing to look at is the tool post holder. Standard, I'm using standard 12mm. You could use 1/2 inch. That's okay, because I'm using 0.7 of a millimetre, between 0.6 and 0.7 of a millimetre shims to bring the tool post, the carbide tip, to the right height. So yeah, you need to make sure that that's sitting at the right height. And there is a method, probably the quickest method in setting the height is using a steel ruler, and we'll just go over that briefly. Okay, I've just set that up, and I'll just show you what we're looking at. We're looking at the steel ruler. and it's leaning slightly backwards, that's the perfect position. You don't want it leaning the other way. You either have it horizontal or slightly leaning back, and that's the right height. So it's just a matter of, after you've got your bar stock in there, there's your carbide cutting bit. Place the ruler down and just turn the crossfeed so that it touches the ruler, just touches. And that will show you whether it's leaning vertical or slightly back. Slightly back like it is now is a desired position. You don't want it leaning the other direction like that. Have it like that. So that's the quickest way to set up your tool post at the correct working height. I do have another piece, a gauge that I made, and we'll just show you that one. So what I've done here is made this on the lathe, and I sit that in that position like so, right? We'll just sort of come around and have a little bit of a look at this. It's interesting. It works really well because a lot of the times there's all different types of tooling. You've got carbide, bits, different shanks. You've got high-speed steel. You've got all sorts of things. Now, one of the ways that a lot of people do set the tool height is with the tailstock, using the dead center or the live center. So what I've done here is now this sets the tool at the right height. It's just a matter that the tool sits just underneath that shelf, and that's the right height. So pretty simple, straightforward, easy tool to use. It's adjustable with the thread, so I can increase or decrease, get it the right dimensions. Alternatively, what you can do, and a lot of people do it, provided your tailstock is set correctly, the alignment, is that you bring the tool right up to the tailstock, wind it in, and you measure the height this way. So that's another way to measure the height using your tailstock. But I do find this time consuming doing this because you've got to wind it backwards and forwards every time. If you're changing, let's just say I'm working on a job here now and I'm changing the bits, and I've got to go backwards and forwards, backwards and forwards. It's much easier if I've got this tool that I made, that I sit it like that and just flip this around and I can check. It's so easy to do it this way without even moving the carriage, and that's why I made it, because it's to check instantly. Now, you may have noticed a ball bearing on there, right? You think, what's he got that on there for? What's the whole idea of this ball bearing? Surprisingly enough, what you use that ball bearing for is that you can come in on this angle here when you put a bar stock in there or a disc, especially when I made these brass discs like this, that when you put anything into this jaw, you're going to have run out. You'll have run out ovality, you'll have run out this way, plus you'll have run out that way. So you can use the ball bearing so that it's straight, goes on to the workpiece this way, and it'll straighten it that way. You can, if you've got a disc that's in the lathe like that, you can use the ball bearing that way and bring the ball bearing up to the disc while it's in the chuck, and it will level it. All right, it'll level it pretty good within at least 1/1000th of an inch if it's done properly. The only thing that you do is that you don't over tighten it when you first put it in the chuck. You just put it into the chuck and lightly tighten it up. Bring the ball bearing, because if you over tighten it, the ball bearing system won't work. You just nip it up a bit and the ball bearing will straighten the workpiece up, and then you retighten the 3 individual points on a 3-jaw chuck. So that works fantastic for alignment and to make sure that the front of the workpiece and the back of the workpiece are parallel with each other. Also, another interesting thing that when we talk about our tooling, there's three types of tooling. You've got tooling that's dead straight. We can actually have a look at that. I'll get one out. Yeah, I've got a piece here. I'll just grab this carbide bit. And this is what we call straight tooling. So when we mount this in there, we can use it to the left and we can use it to the right. We can turn it this way or we can turn it that way. So we can use it. It's very flexible. The only downside on this is you've only got two tips, one here and one there. Whereas on this one here, it's a triangle. And the triangle means that you've got three different tips that you can use. So when one goes blunt or broke, and they're easy to break. That's the other thing that you'll notice with a lot of this tooling. Very easy to break carbide tips because they're brittle. Now, you'll notice if you look at this tooling, I've also got brass shimming under here, about 0.75, so we're at the right tool height. You'll notice that this tooling faces to the left. But because it's faced to the left, it's actually called a right-hand cutting tool. The reason that it's called a right-hand cutting tool, even though it faces to the left, is because when you start the lathe and you engage the tool, it's cutting from the left side. It starts from the right side and goes to the left. That's why it's called a left-hand cutting tool. Same as a right-hand cutting tool. It starts at the left, right, and it cuts that way because you might need to make a shoulder on the right-hand side. So, therefore, if you've got a left hand and a right hand, it means that you need to buy two. Whereas if you've got this type of cutting tool, you only need to buy one because it can do left hand, it can do right hand, it can move into tighter places much better than what that can. The other thing is also, do you need to put this tool parallel with the workpiece? What is the correct position of the tool? As what is the correct position of this tool? I've also got other tooling that's more like a square shape. We'll have a look at that. Because I've just shown you a diamond shape. This is a triangle shape. And I can show you another shape that's square shape. Almost. It's 80 degrees. And that's this one here. Right? Looks like a bit of a diamond as well. The reason that it's 80 degrees is for clearance. You need clearance on every little bit. You can't have the edges of the carbide bit rubbing up against the side of the workpiece. There's got to be some clearance. So you need at least a minimum of 5 degrees up to 10 degrees. So you could quite easily have 85 degree angle, and with an 85 degree angle you'd have 5 degree clearance. So that's the whole idea of having a clearance angle. Whether you use high-speed steel or carbide tips, it really doesn't matter. And it also really doesn't matter how the tip touches the workpiece, as long as you've got some clearance. And also, long as the radius of the tip. The radius on a lot of carbide tips is 0.5 or 0.8 of a millimetre. If you put that radius in straight like that, you'll get a better finish. If you have less radius because you've angled your tool post at a different angle, so you're off the radius, you won't get as good finish. So just remember that the cutting tip you should be cutting on the radius. Now, when you customize your high-speed steel, which I do use, you can put a much larger radius on them and you can get a much better finish with a larger radius. Here's a tip that I've got here. This gets into nice little spots, gives a reasonably good finish, but with a larger radius you get a much better finish like this one. Look at that radius tip. That's got a huge radius on it, right? So when you take this to your workpiece, you can come in at different angles because you've got that radius. You'll end up with a great finish whether you're straight, whether you're this way or that way. So yeah, putting radiuses on your high-speed steel really does work good. So yeah, you can customize a lot of those things with high-speed steel. And here's another bit that I did for another job. It's very, very interesting what you can come up with the carbide tips and what you can come up with the high-speed steel tips. Now, here's a here's a high-speed tooling that I made, very, very small. What this is actually for was after I used a center drill. When you use a center drill at the end of a shaft, you'll never ever get it perfect. It'll be about 5 thou out. The same as when you hold something in the chuck. It'll never be perfect in the middle, the working piece. You'll always be a few thou out. What you can do to try and center that much better is use a dial gauge, and you can loosen, turn around to a different position, then turn it by hand and check against a dial gauge. So a dial gauge can really help to see whether your work has much run out. It's quite normal to get a lot of run out. And what I did the other day was try to make a bit of a test bar, and we were about a thou out here, right? So what we did was use this high-speed steel so that we could, a little bit blurry there, see if we can get that focused a bit better. We use this high-speed steel on a 30-degree angle to go in there and to keep that center as best as possible. Because the error that you get using a center drill, you can be a couple of thou out. It's not a problem if you are turning, but I was trying to make an alignment tool, and that's another subject about aligning the tailstock with the alignment here. So it's interesting when you're using a lathe how many inaccuracies that you can get from all of the lathe, the combination. You've got your spindle clearance. So if it's worn, you can get movement in here, backlash backwards and forwards. The worn chuck parts, so they can cause problems. Your spindle alignment is another problem. Your cross feeds, your apron, your bed, your tool holder, everything in this area can be worn and can have movement and can all make a huge difference when you're turning something. So you need to be aware of how to do a basic alignment. And a basic alignment is bringing your tailstock up, that your tailstock is in correct alignment, and you do have screws on your tailstock here that you can move the tailstock forwards or backwards, and what that will ensure is that the lathe is cutting the same amount of material. If we put a long section in here and we only taken a couple of thou off at this end, that it's taken a couple of thou off at that end. And also when we look down from this way, so you've got horizontal alignment and vertical alignment. And hopefully you're fairly accurate, a half a thou. If you can get your lathe within a half a thou of vertical and horizontal alignment, it's going to do most of the type of work that you need to do. Now earlier before we did speak about the different speeds, about how the motor pulleys have got two different pulleys selections that you can put. The belt can move on the inner pulley or the outer pulley, plus we've got 4 different pulleys here. So that's a total of 8 speeds there, plus you've got the back gear that's going to drop it down to around about 60 RPM, and the motor can go to about 1,440 usually in most cases. So I think I've covered most areas. The only other thing that I probably haven't spoken about is if you're doing threads and some of these controls. So this is just going to move the carriage backwards and forwards. Okay, pretty straightforward. You got this nut down the bottom. Now that nut, when the cross feed is engaged, that's your clutch, right? So you can engage this cross feed using this lever here. This lever moves into different positions, right? So then you can automatically send that across that way. As well, when you engage, this is called the half nut lever. The reason it's called half nut, when you see this square ground shaft, you've got a nut that's about this long, it's split in half, and they open up like a V, and they clamp onto the square ground shaft that's revolving. So when you engage this, they clamp onto the bar and it sends a carriage that way based on the speed that you set on the gearbox. So there are your controls there. Generally speaking, I don't use the cross feed going across. I just do it by hand. The other thing is, if we zoom in there, you'll notice they did come with a little grub screw, and you used to use a screwdriver, but I just put little cap screws on there. You can just undo these and tighten them up, and that way you can use your numbers to 0. This is in thousandths of an inch. I only use metric, so 10 thou equals 0.25 of a millimetre. So a lot of the times when I'm doing cuts, I'm only doing them in 10 thou increments. This lathe can't take big cuts like 5 millimetre. It's only a small lathe. The longest piece bar that you can turn on is around about 450 millimeters. But having said that, you can turn something a lot longer if you were to use the steady. And what I mean by that is that's a steady here. So you could put a bar in 4 foot long, adjust these, take out the tailstock, right? Remove the tailstock, put the steady in there, and you could have a much, much longer bar if you had to turn in one particular section of that bar. So this is the cover that comes down for safety. I leave it up and I normally leave the belt loose. I take the tension off it so that it's loose. Nothing worse than having it left under tension all the time. The only other thing that I'd like to mention, and I mentioned about before that it's critical, this lathe is 72 years old. And if this bearing has lasted 72 years and it's a metal spindle on cast iron, has a little oil reservoir down the bottom, and this flippy cap here, when you flip that up, squirt in the oil. It has a little spring with a little wick on it, and that little wick touches the bottom of the spindle, keeps it lubricated at all times. It does have a little tiny shim in there, so that's something that really got to be careful of. You really need to know what you're doing before you touch any of this, especially if you're going to remove it. You really need to know what you're doing. You do have a roller type bearing system on the back here, but on the front, metal on metal. 72 years and it's still going good. I can't feel any movement whatsoever in that chuck, whether it's vertical movement up and down or movement side. It is as solid as a rock and it spins freely. It was, I don't know if how much maintenance it's ever had. This is a problem. You get something that's 72 years old, who knows what was done with it? No idea. The only thing is, its best friend is the oil can. And make sure that you oil these flippy caps every single time you use this lathe, and it's going to give many, many more years of service. Hopefully I've covered, the only other thing that I didn't mention was you got this dial, this chaser. Now this chaser has numbers on it. They spin around, this gear touches the bar here, engages with that, and when it was used for imperial and you're doing thread cutting, you didn't need reverse. You'd go by using this thread chaser gauge here. They do have a metric version, but I've got reverse, electrical reverse on here, right? So that's the electrical switch that I've got there, forward and reverse. So when I do threads, I use, now interesting, if I just briefly talk about doing threads, we done one here the other day, was when you do a thread like this, you've got to be extremely careful because I'm doing a thread up against a shoulder, right? Now, when you're doing a thread up against a shoulder, you have to stop the lathe, switch it off, right? So there's the off-on switch down the bottom there. When we put the lathe, the back gear in position, there's a little pin here. You pull this pin out, you pull the back gear into position, and you're lucky if you've got about 70 RPMs. That's how slow that goes. And then look how slow that's going. So if I engage at that speed, it's moving very slow. But when you're cutting a thread and you're onto a shoulder like that, you need that slow speed. Believe me, you do need it. So that's where I use the back gear to slow the lathe down. If I take that back gear off, I'm going to be spinning, and now you need to pop that back in. So I'll just turn that round. That's it. It's popped back in. Now that's back to normal speed, which is going to be about around 500 RPM. So that's how the back gear works. Because the feed is going to be a lot faster now. Look at the wheel going around. And when you come up to a shoulder like that at that speed, it's easy to damage. Those carbide tips are very easy to snap and break. So one of the things that you've got to get used to is that when you come up to a shoulder, you have to learn to, one hand is holding this, we're going to wind this out. As soon as it comes up to the shoulder, I hit the stop switch and wind that out. If you don't wind it out, you can snap off the carbide tip. So yeah, be very, very careful tapping threads. One of the other things is that when you engage the half nut into tapping a thread, is that you don't disengage this. This stays fully engaged. So when we are doing a thread, it's locked in a position now. So you can see that moving around. When we get to the end, we turn the motor off and wind it like that. Say one turn. That'll pull the carbide tip out of the tooth. Then we put this into reverse, right, like that. And you'll notice we're going the other way now. So then we go past the thread, turn it off, put it back into forwards. Make sure you know you've set your reading off here to know where you are. Wind this back into the correct position and start your next pass. When you're doing a thread of 2mm pitch like this, it's about 7 or 8 passes, right? So what I'm essentially doing is doing a loop like that, right? You can't disengage this. You disengage this, your carbide bit or your high-speed steel is going to be out of position and you're going to screw everything up. So just remember, if you're doing threads, this is engaged, it's left engaged, you have to stop the motor, screw this out of position at the same time, put it in reverse, send it back, screw that back in the right position, it's in the forward position, do your second pass, your third pass, your fourth pass. Use your thread gauges and check for depth until you got the right depth. Take little passes until you get really familiar with cutting threads. It's really not that difficult, especially outside threads. Inside threads a little bit more tricky. Can't see as good. It's a bit like doing a blind cut. Look, this video's gone for 41 minutes. Hopefully I've covered a large area of the Hercus lathe and what it's capable of doing. Back in the day it was a precision lathe. This doesn't have enormous amount of wear on it for how old it is. Remarkably, it's quite old. If you do have wear in your lathe and you know where the lathe is, where the wear is, you can compensate for it. But you do need a test bar, a proper graduated test bar, 4 digits, up to about 4 microns. You can put it between centers. You can buy a proper center. You can take the chuck off. You can put the center on the spindle. That's the most accurate way of doing it, because any chuck will give you an error unless you use a 4-jaw chuck. You could put a parallel dead center in a 4-jaw chuck. You'd have to use a gauge to check for run out. Run out is going to be a problem on a 3-jaw chuck. It'll be a problem on a 4-jaw chuck, but you can eliminate run out on a 4-jaw chuck. So setting the lathe up is another episode that we can do and show you, if you've got the equipment, how to properly align the centers, vertical and horizontal, so that the lathe is, let's just say we were turning something that was 20 millimeters on the dot. It needs to be 20 millimeters on the dot at this end, because if your lathe is out of adjustment, your tailstock is too far towards you, or it's pushed away from you, you do have an adjustment on the tailstock. There is a bolt on either side. There's a little mark on the back. That's the center line mark there, right on the back. So you do need to occasionally align it. The other thing about alignment on a lathe is that anytime you move the lathe, all right, you transport it somewhere, like in the garage. If I was to pick it up and move it to another part of the garage, you should really check for alignment again. You'd be surprised how the tailstock could go out a bit. If you don't use a tailstock, you probably don't need to worry about it a lot. The other part that wears a lot on the lathe is the bed, right? These rails on the bed can wear. Your biggest friend is your oil can. Doesn't appear to be enormous amount of wear on this bed in the 72 years, so I'm thankful for that. There is a little bit, but not enough for the work that I'm going to do. Most of the work that I'm going to do is probably only going to be about that long. I'm only going to work in this area. I'm not going to work the full length. I never wanted a lathe for long spindles or long bits of metal. I've got no need to do that. But if I did, I could always use the steady as well. So there's all different ways of doing things on a lathe, but you need to check its accuracy if you want to manufacture something under a thou variation, right? So yeah, if you can get under a thou or a half a thou variation between this end and that end, then your lathe is set up really good. But if you're getting a lot more than that, then your lathe needs to be aligned. And you can compensate quite a lot if you know where the error is. Look, I hope this information helps. It's aimed at the hobbyist, the beginner. We'll do a few other videos with different other things that we can do on a lathe. So I'll have a whole series of different videos and address different issues as we go along. Thanks for watching. Bye for now. And look, you're quite welcome to put comments in, because I really enjoy the comments. So thanks for watching. Bye for now.